Hey everybody, welcome back. What we're going to do in this video is look at some what I call simple optical systems involving a single positive lens. I'm still using the same PowerPoint presentation. I'm just going to go down and start right here. So we learned in the last video how to do the ray trace for an arbitrary positive lens, and we introduced thin lens equation and lateral magnification. Now we're going to look at some specific geometries involving a single positive lens. So the first one we're going to look at is what we call a camera. Then we're going to look at a projector. Then I'll end this video, this will be a rather short video, and we'll look at what we call a magnifying glass or magnifier in the next video. So these two that I'm going to talk about today, they're both going to use real image formation by a single positive lens. Now the camera, what we're going to do is place the object outside that front focal point, to the left of it, but relatively far from the lens. So something like that. So when I say camera, you guys should think, okay, single positive lens, object is relatively far away. I've indicated the focal points of my lens, both the front and the back. Here's where we see the usefulness of the front focal point. It's again as a reference point for where the object is. Okay, so let's do the ray trace. In fact, what I invite you guys to do is just stop the video and you do the ray trace on a piece of paper. So don't just rely on looking at these ray traces, actually practice them on paper so that you can do them. And for instance, on a test, I might ask you to do a ray trace. Okay, all right. So let's go ahead and do the ray trace. Here's our first ray. It's always from the tip of the object arrow parallel to the optic axis. And since this is a positive lens, that has to go through that back focal point. Any ray parallel to the optic axis is going to go through that back focal point. The second ray that we always sketch goes straight through the middle of the lens. I don't care if it's a positive or negative lens. It goes straight through the positive lens in our thin lens approximation. Okay, now look, these two rays are definitely converging. They're converging, though, and intersecting right here. So if I fill in my image arrow, I can see that it's going to be inverted. It is a real image. There is light being converged and focused right there where that arrow is. And the image is smaller than the object, which is why we call this a camera. Because if you think of a typical camera, this is what a camera does. Think of you taking a picture with your phone, for instance, your phone camera. The object is relatively far away. The object distance is much larger than the focal length of the lens, and the image is formed very close to the lens. Think of your camera. It's got to be formed extremely close to your lens. It will be formed outside of the focal point, the back focal point, and it's going to be really tiny. Okay, so that's why we call this geometry the camera. So the camera, again, positive lens, object outside the focal point and far from the lens. And if you forget that you get a real inverted image smaller than the object, just do the ray trace, and the ray trace, if you do an okay job, will tell you that. Okay, so that's the camera. Now the next thing we'll do is we'll just move the object closer to the lens, but we're still going to place it outside the front focal point. That is going to produce what we call a projector system. So here we go. And again, I invite you to stop the video. Right? Try this on a piece of paper. Just put a lens, put two dots equidistant from the lens as well as you can. Draw an arrow close to the lens but outside the focal point. Do the ray trace, see what you get. All right, what do you get? Here's the first ray parallel to the optic axis. It's got to go through that back focal point. And then the other ray has got to go through the center of the lens, right there. Okay, intersection right there. Draw in your image arrow. You got it. So how would you describe that image? Is it real or virtual? It's real, right? Formed with converging rays. You put a screen right there. You'll see the image, provided you have enough light coming from the object. Is it inverted or non-inverted? Compared to the object, it's inverted. Is it bigger than or smaller than the object? If we look at its lateral dimension, it's definitely bigger. So there you go. That's the projector. And this is how a simple projector lens would work. If you think of the projector in our classroom, it projects a real inverted image. Now, we don't see it inverted. We don't think of it as inverted, but the LCD screen inside the projector, the object, it's a transmission object, the light's going through it, but it is inverted compared to the screen image. And the image on the screen is bigger than the object, that real inverted image. Okay, so if I say projector, you should think of a positive lens, object outside the focal point but close to the lens. And then realize what you're going to get is real inverted image bigger than the object. Okay, that's it for this video. The magnifier, I want to spend some more time on, so I'm going to make that a separate video. Practice your ray tracing. I'll see you in the next video. Bye-bye.